So in this problem, your brother suggests playing game pond A because there's more ducks in pond A that have an X than in pond B. However, that it completely ignores the aspect of yes, there's more ducks, but more ducks out of how many total? So it's not just that there's 23, but it's 23 out of the 60. So I really have to look at what percent of the pond ducks are having an X. So if I look at pond A, I know that that would be taking my 23 out of 60, and I would then divide 23 divided by 60, and I would get 0.383 with the repeater, which is, as a percent, 38 and 1/3%. Now, if I look at pond B, again, I want to look at not how many, but how many out of the total. So there's 13 out of 32. And then if I divide this, when I divide, I get 40,625 100,000ths, which, when changed to the percent, is 40 and 5/8%. So while there's fewer ducks, it's more out of the proportion of the total. So I'm better off playing pond B instead of pond A based on how many it is out of the total. So that's more important. All right, so now I'll get into the bear game, and I want to look at how can we change the probability of making it more likely that you can get a green bear. So you have to first recognize what's the probability of getting a green bear in the first place. Well, I have 7, 5, and 4, so I know that I have 7 of them are green out of, well, 4 plus 5 plus 7 is 16. So currently I have a 7/16 chance of pulling a green bear, which is just under 1/2. Now, the idea here is that I'm going to add more green bears. So let's just do a little bit of playing. So say maybe I'm going to do a green bear plus one more bear, one more green bear. That would mean that I would have 7 plus that one new one. But I also have to think about what's that do to my denominator. I had 16, but I just added another bear to it. So now that would become 8/17. Well, that's still too low, so maybe I just take a guess. What if I started instead with the idea that maybe I take that probability of my green, and I'm going to add 4 green bears. That would mean that I'd have my 7 bears, and I'm adding 4 more, but what I have to remember is that I'm adding 4 to the total as well. So that would become 11/20. So I'm getting closer. But what I can notice here is that however many I add to my numerator, I add to my denominator, and I know I'm trying to get to 2/3. So I can actually set up an equation here and a proportion where I know that that probability I'm looking for is 2/3, and I've got the 7/16, but I know I'm trying to add some new number of bears that are green, but I have to remember that if I add more green bears to my numerator, that's also changing how many total bears there are in the box. So from here, this looks kind of crazy for a lot of people, but it's really just a basic proportion that I cross multiply. I just have to remember that when I cross multiply here, I get 2 times that quantity, 16 plus x, and I get 3 times the quantity, 7 plus x. So that the first thing I have to do instead of it being a direct multiplication is I have to distribute. So I get 32 plus 2x, and here I get 21 plus 3x. So I want to subtract 2x from both sides, and at the same time, just to expedite this, I want to subtract 21 from both sides. And see, that cancels my 2x's, cancels my 21. I'm left with x equals, and 32 minus 21 is 11. That would mean I need to add 11 green bear. So let's see if I do this. If I do 7 plus 11 over 16 plus 11, that would give me 18 out of 27. And if I divide them both by 9, I would get 2/3. So I know it works. So I can always go back and check it once I find it. So I'm going to take that same idea here. Now it's with the blue bears. So I know that the probability of a blue bear is 5 blue bears, and we still started with 16. So here again, we're trying to increase my probability of blue bears. So I need to add blue bears, which means I'm also going to have to add to my total. And I'm again trying to get to 2/3. So the setup is very similar. I know that I would start with the 2/3, and I know that I'm adding some blue bears. I'm going to put a B for blue. And if I add more blue bears, I'm also adding more blue bears to my total. So when I cross multiply, again, that's 2 times the quantity 16 plus b, and that's 3 times the quantity 5 plus b. So here I distribute, again, that gives me 32 plus 2b, and this would give me 15 plus 3b. And again, I can do my order of operations. I'm going to subtract 2b from both sides. And just to expedite it again, I'm going to subtract 15 from both sides at the same time, so that I get that b would equal 17. That means I need to add 17 blue bears to make it possible. So let's see if I do that. 5 plus 17 and 16 plus 17. This would give me 22 in my numerator, 33 in my denominator, and if I simplify 22 33rds, I would have 2/3. Alright, so here is one that's a little bit different than the others. Here I'm adding blue bears to change the probability of my red bears. So what I'm really looking at here is changing the probability of my red bears. So where I first want to start then is thinking about, well, how many red bears do I have? My probability of being a red bear is 4 out of 16, which is, if you want to simplify, 1/4. So it's at 25%. So I've got too many bears right now. Now I want to do just a small thing here just to help out. If I add a blue bear to the amount of bears I have, so I'm going to say the probability of red plus 1 blue bear. Well, when I do that, have I changed the number of red bears I have? No, it's still just 4 bears. Have I changed the number of total bears I have? Yeah, I've now gone from 16 to 16 plus that 1 blue, which takes me then to 4/17. So the idea here with this one is I'm not changing both my numerator and my denominator. I'm only adding more bears total. I'm not changing the number of red that I have in the container. So when I think about how to set this up, I would have 1/10 would equal my 4 red bears, and then that's going to be 16 plus some number of blue bears that I don't know. So when I cross multiply here, I get 1 times 16 plus x equals 40. Now when I distribute 1, that just gives me 16 plus x equals 40. So I subtract 16 from both sides, and that I will get x to be 24. So if I think back here, 4 over 16 plus 24, 4 over 40, well, that's 1/10. So that's how it's a little bit different than the other problems.